Hello class, how are you doing? In this video we're going to talk about the area, or better say finding the area and the arc length, and maybe we get time to get to the surface area in polar coordinate. In the Cartesian coordinate plane, like when you have y equal to a square root of x, and then you take that area bounded between 0, 0 and x equal to 1. What we did, we were able to divide into many rectangles, and either we do the right corner or we did the left corner and maybe the midpoint, and we said all this delta, this length, the width are delta x, and the height, that's for the ith rectangle, first, second, third, fourth, fifth, sixth, I don't know which one, that's the ith one. And the height is going to be the height of the same thing. Is either the I or I minus 1 or I plus I minus 1 over 2. Right corner, left corner, or the midpoint. And we took that area and we sum it up from the lower limit of x to the upper limit. And as delta x approaches 0, these two distances got almost close to 0 and it become a full curve. And if you remember, we said we have a numerical approach called trapezoid, and we also divide it into a trapezoid too. But what happened if you have a polar function of r equal to 2 plus 2 cosine theta, and since the ratio of a over b is 1, that represents the cardioid, and when theta is 0, you know your r is 4, but when theta is pi over 2, that is 2, and when the theta is 180 degree, that make it a 0. Therefore, if I want to find the area of that one, and the other piece is going to be here, you know at that point the function is not differentiable because you have a cos there, and also you need 360 degree to get the cardioid. But since between the 0 and all the way to 2 pi there is a point that the function is not differentiable and has a cos, you cannot go from 0 to 2 pi. But these two are symmetric. You can go 0 to pi and sum up stuffs. What are the stuff? In here, dividing into this one to horizontal rectangle, then I don't have any y to make it fixed. If I divide it into a vertical rectangle, I don't have any x like here to make it fixed. Over there you could make it either the y fixed or the x fixed, but I don't see no y and x. I see r and a theta. Therefore, when it comes to polar coordinate, you have to divide everything from a pole, and this is one r, this is another r, and this is nothing called except a sector. Therefore, if you have a circle, it's just like a pizza. It's easier to cut it in pieces, and every one of these pieces are eatable. There is no waste at all. But if you take a cardioid and cut it into a rectangle, and you say divide it among people, there are so many small corners here that you have to throw away. Therefore, dividing the cardioid, the graph of a cardioid, into a rectangle is not a good choice. Therefore, I have to do sectors. Then what is a sector? Sector is a segment of, in this case, is a circle. I find that area, and find out that how many of the same area is inside here. Therefore, if this area is, I'm assuming this is 2, I multiply how many of these sectors we have, I get the total area. But how do you find the area of that piece? Remember, the total angle of a circular angle for a circle is 360 degree or 2 pi. And you know the area of a circle is pi r squared. Therefore, you should know the area always eats up half of the given angle to find the area, only half. And this is go back to geometry, cut it in pieces and change it to trapezoid and things like that. But just remember it's half. But when it's a distance around the circumference is 2 pi r. Distance or arc length is always eat up all the angles, but area is half. Therefore, if I have a sector here and said this angle is theta, the arc length, which is a S, I cannot call it C, C is a circumference, eat up all that angle multiplied by r. See, same formula, all the angle multiplied by r. And the area eats up half of that angle times r squared. See, same formula as the area of a circle and the arc length. Then I know the area of an arc length is this. I take this one and sum it up and find the area of a cardioid. And the question is, if you have a cardioid of r equal to 2 plus 2 cosine theta, you have to know where is the cusp. Sometimes the cusp, it depends to the cardioid, is at pi. Sometimes the cusp is not at pi. Maybe it's at pi over 2. Maybe the cusp is at 3 pi over 2. I don't know where the cusp is. Then you have to know at least something about the graph. If you, when theta is 0, is 4, 2, 0. I know my cusp is at pi. I'm going to divide it into a sector. What am I dividing? I'm dividing the 180 degree angle. Therefore, I go from 0 to 180. But because these two are symmetric, because it's symmetric, I double up. And I put 1/2 r squared d theta. If I write in this problem, here is a theta 1, here is a theta 2, and take that 2 off, and I guarantee theta 1 is less than theta 2, that becomes the area of any polar graph. Any polar graph. What I was saying, any polar graph, any region bounded by two angles using polar graph. Therefore, that's called the area of a region. It could become inner loop, it could be a cardioid, it could be between the circles and a cardioid, a region bounded by polar graph. If I'm talking about this one, that's any. But somebody said, what is the difference between this region and this region? What it makes the region different is the R. In the angle, both the same, 0 degree, power 6, power 3, power 2, power 120 degree, pi. R is the one makes it different. And as the R makes it different, the graph is going to be different. Then for the cardioid, I go 0 to pi 1/2 r squared d theta, and I'm going to double it. Somebody said, then what is R? R represents different polar function. If you want to find the area of a circle, instead of r, you put cosine theta. If it's a cardioid, you put 2 plus 2 cosine theta. If it's a rose curve, you put 2 sine of 3 theta. But what it is different what region, and the lower limit and upper limit is important. Therefore, for the cardioid, is 1/2 times 2 is 1. You go 0 to pi. R is a different. And what is your R? 2 plus 2 cosine theta square d theta. And how? First you have to square that, which is 4 plus 8 cosine theta plus 4 cosine square theta. This is integrable, that's integrable, but not that one. You cannot integrate cosine, sine and cosine to an even power. You have to do power reduction. Then everything is integrable. What is the area? That's 4 times 1/2 is 2. 2 plus 4 is 6 plus 8 cosine theta plus 2 cosine 2 theta d theta from 0 to pi. Therefore, the answer to this one is 6 theta plus 8 sine theta plus 2 over 2, because that's the u. I need a 2, I have to divide it by 2. Sine 2 theta from 0 to pi. 6 pi, I put pi for theta. Sine of pi is 0. Sine of 2 pi is 0. When I put 0 right here, 6 times 0 is 0. Sine of 0 is 0. That's 0. The answer is 6 pi unit square. That is the area of the cardioid, only represented by 2 plus 2 cosine. But you said, what happens if I have R equal to 4 sine 2 theta? I know this is a special graph called rose curve, and you're going to have 4 rose petals. All 4 roses have same area. Therefore, I'm going to find the area of one of them and multiply by 4. How do you know what is the lower limit, what is the upper limit? All of these entering the region, exiting the region, is happen at the pole. At the pole. At the pole, R is 0. Therefore, I put 0 for R divided by 4. And I'm going to say sine of what angle is 0? That angle must be n pi. 0, pi, 2 pi, 3 pi. Then I divide it by 2. Then your theta is n pi over 2. Then for n equal to 0, your theta is equal to 0. And your R is 0. N1, your pi is 2. That's 0. N2 is a pi. R is 0. N3 is 3 pi over 2 and is a 0. N2 pi is 2 pi over 2. I'm sorry, 4. 4 divided by 2 is 2 pi and is 0. See, these 2 is one rose petal. That 2 is another rose petal. That 2 another rose petal. And that 2 is another rose petal. Therefore, when R is 0 at 0 degree, it's gonna go someplace in middle of these 2. Middle of these 2 is pi over 4. And if I put 2 times pi over 4 here, pi over 4 is pi over 2. And sine of pi over 2 is 1. 1 times 4 is 4. At pi over 4, it reaches 4, and it comes back right here. Therefore, this is your lower limit, that's your upper limit. Therefore, when R is 0, but do me a favor, don't pick the first one and the third one. The first one and the third one, you're going through 2 regions, and between them, there is a what? There is a cusp, and you cannot integrate it. Therefore, here I'm going to go from, somebody said, can I go from pi to 3 pi over 2? Make your life miserable. Do whatever you want. Can I go right here, when I go from pi over 2 to pi? Make your life miserable. Do whatever you want. You can go 3 pi over 2 to 2 pi. But I like the 0 to pi over 2. 1/2 R squared. The R make all the function different. D theta. What is 4 squared? 16. What is 16 times 1/2? 8. What is left? Is left with the sine square of 2 theta. But you cannot integrate sine square. You have to do power reduction, and that's make it cosine of 4 theta. When I multiply, I already took care of that 4. 16 times 2 is 1/8. You don't have to multiply this one by anything. Then I'm going to integrate this, and I'm going to say 8 1/2 theta minus 1/8, because you have to multiply by 4 divided by 4. Sine of 4 theta. See, 0 to power 2 make your life easy. And what happens if I put theta by power 2? It becomes 1/2 power 2. And what happens if I put power 2 for theta? 4 times power 2 is 2 pi. Sine of 2 pi is 0. 1/2 times 0 is 0. And sine of 0 is 0. That's all your answer. 8 times power 4. And it's 2 pi unit square. But please remember, I put 1/2 0 to power 2. That's the area of 1 rows. If they ask you give me all of it, multiply by 4, 8 pi. If you said 3 of it, multiply by 3. And if you said 1 of it, is a 2 pi. Then sometimes you get something like this, or equal to 1 minus 2 cosine theta. You know A is 1, B is 2. The ratio is between 1 and 0. That's called the inner loop. This has a loop. Line and sun with the inner loop. When theta becomes 0, cosine 0 is 1. 1 minus 2 is negative 1. Therefore, when it's 0, you have a negative 1. But when it's pi, cosine of pi is 0, you get to 1. But when it's, I'm sorry, power 2. When it's power 2, cosine of power 2 is 0, and you get to 1. And what happens when it's pi? Cosine of pi is negative 1. That's make it 3. It go here. Then I have to here determine when am I going to pass it through the pole, because with all these 4 points I'm confused. Let's do it. R0 is 1 minus 2 cosine theta, and 2 cosine theta is 1/2, because this comes to this side become positive. And the cosine corresponds to x. The maximum the cosine take is 1. 1/2 is right here. And if this is the y-axis, this angle is pi over 3 and 5 pi over 3. Therefore, whenever I draw this one, at pi over 3, I'm 0. But when I had a 0, is negative 1. Therefore, I am reaching 0 at pi over 3. But I don't know if I have to come this way or this way. That orientation matters. You have no choice, because you can go either way. Pick a number right here, pi over 6. Just see if that number is negative or positive. That's all you have to do. If it's negative, it's coming that way. What is cosine of pi over 6? Radical 3 over 2 times 2. Radical 3, 1 minus radical, that's a negative number. Therefore, for pi over 6, you have a negative number. Therefore, your trace is coming this way. Then you go to 1. Then you go to 3. Then at 5 pi over 3, which is right here, it come back to 0. And at 2 pi is the same as the starting point. Go to negative 1. Then the trace is very important. That's my trace. Then if I ask you what is the area of the inner loop? Well, I went here from 0 to pi over 3. You can find that area and double it. 0 to pi over 3 and double it. 1/2 r squared d theta. And 0 to pi over 3, I'm talking about that r. But somebody said, I want to use the whole thing. Here you have an issue. Because entering the region is not that way, because orientation was that way. But you could enter the region that way. And what was that? That was 5 pi over 3. But I cannot put 5 pi over 3 in the bottom and put pi over 3 on the top, because these have lower limit have to be less. But this is nothing except negative pi over 3. Or I can do here and say negative pi over 3 all the way to pi over 3. See, a negative pi over 3, 0, 0 to pi over 3. And I don't have to double it. 1/2 r squared d theta. There is many ways you can approach those problems, but you gotta have the correct lower limit and the upper limit. But somebody said, what happens if I want an area inside that region between the loop? Remember, that inner piece is a live animal. It can move. The whole underneath is empty. What was this angle? That was pi over 3. And what was this one right here? All the way here was a pi. And that piece is going to take care of that piece. You got to double it. 1/2 r squared d theta. You get the area between the loop. But maybe one of you asked and said, what happens if I have another polar function r equal to 1? Remember, this one was 1. Therefore, this is right here. And somebody asked me, I want the area of a region bounded, but let me say it that way. Between the what? Between the, the polar graph, between. Between is here. Not common. This is called common because that's also, let me see. This is between this and between these. Yes, that part is good. That's the between. But if I do this one, I want to say between the region. Okay, and that could be also a between. And that could be also a between. Then how do you do those? Here you have to know at what angle you're going in here, what angle you're coming out. Then you do need to find point of intersection. What is the point of intersection? These two become equal to each other. 1 become 1 minus 2 cosine theta, and that 1 and 1 is gone. Negative 2 cosine theta becomes 0, and cosine theta is either 0 and theta is either pi over 2 or 3 pi over 2. My graph is not perfect, but I bet you this one is at the angle 3 pi over 2, and that should be pi over 2. My graph is not a perfect graph. That's what I got confused. You need to find the point of intersection. Let's do an example and see where you're going to use point of intersection. You have r equal to negative 6 cosine theta and r equal to 2 minus 2 cosine theta, but I have to graph it very clearly. If I use my graphing calculator right here, you're going to see the clear graph. Then I'm going to graph based on here. This one is negative 6 cosine theta, and I have 2 minus 2 cosine theta. I do need 360 degree. That should be 2 pi, not e. And the theta step, pi over 12 is good. And my x, I go from negative 8 to 8. I don't know how much I need. Y, negative 8 to 8, and a 1. And I'm going to graph. Syntax. Syntax, I put minus, not negative. That should be negative. I got that graph. And also that graph right here. One of them is a cardioid, and one of them is a circle. If I go to my window and set from negative 4 to 4 and negative 4 to 4, maybe I see my graph better. See, that's a circle. Let me see if I did my graph of a card. No, I didn't put the cardioid correctly. That's 2 minus 2 cosine theta. I'm going to say, why am I not seeing my cardioid? See, that's the graph, and that's the graph of a cardioid. I want a region which is bounded by both graph. Both means not here, because this is below that one, but if I do here, is contained by both of them, is underneath of this and is underneath of this, is underneath of that one, is underneath of that one. I want to find that area. Well, I want to find that area, I'm going to double it. But I need to find that point of intersection. Therefore, I have to say negative 6 cosine theta equal to 2 minus 2 cosine theta. And by moving the 6 cosine to other side, it becomes positive. And that I'm going to bring the 2 to this side, and that becomes 4 cosine theta. Therefore, my cosine theta here is negative 1/2. Therefore, your x is negative 1/2. Therefore, this is 2 pi over 3 and 4 pi over 3. That's the point of intersection. Let me graph this. I know this is a circle with a diameter of negative 6. 1, 2, 3, 4, 5, 6. This is a circle. This is a cardioid. When the theta is 0, you have a 0. When it's pi is 2, pi over 2 is 2. And when it's 180 degree is 4. When 3 pi is 2, and you go right here. Therefore, do you see that's point of intersection, and that's the point of intersection. That point of intersection is theta equal to 2 pi over 3, and that point of intersection is 4 pi over 3. The region, I want to take that region, but please remember, that region has two pieces. Part of it is under the cardioid, part of it is under the circle. I have to separate those. That's the part under the circle, that's part under the cardioid. What is that point? That point, the angle is 2 pi over 3. And how much is that? That's the pi. I have to double it, and also I'm going to cut this one. Double it for that piece, 1/2. Which R I'm using? I'm using the R of the cardioid, not the circle. And the R of a cardioid is 2 minus 2 cosine theta squared d theta. That's take care of these two pieces. But everybody think that angle is a 0 degree. Please watch. When cosine become 1, theta becomes 0, become negative 6. But when it become pi over 2, you get 0. Therefore, this one for a circle, R is 0, angle is pi over 2. I am using the circle, not the cardioid. If I was going to use the cardioid, well, when the theta is 0, I get 4. No, when the theta is 0, I get 0. Therefore, for the cardioid is 0, 0. You cannot use 0 degree. You gotta use the angle belong to the circle. And for the circle, that point is r is 0 and pi over 2. Therefore, I go pi over 2 for the circle to 2 pi over 3. I have two pieces. I double it, 1/2, but I gotta use the r of the circle. And what is the circle? -6 cosine theta squared d theta. Then you can use this to find the area is a common area to both regions bounded by the circle and the cardioid. You need to be very careful. When you do this lower limit and upper limit, that must belong to that r. Whatever r is using, those lower limit, upper limit, you must have a corresponding r. Therefore, that r is a cardioid, you use those angle. This is a circle right here, you have to use the circle. Here, everybody look like pole, 0, 0. No, it depends which r you talking about. Here, if the theta is 0, your r is 0. But I'm not finding the area under the curve of the cardioid, I'm going to do the circle. But for the circle, when I put right here, pi over 2, I get 0. When I put 0, I get -6. Therefore, for this one is 0 and pi over 2. And you go to 2 pi over 3, which is 120 degrees, and find it. I hope you enjoyed it. I couldn't finish the whole thing. The next video is going to become the arc length and the surface area. Thank you.